Hi, everyone. I'm going to be talking about TUIs today. First of all, why should you be listening to me about this? I work at FP Complete. I do a whole host of things, and I like writing TUIs. Recently, I've also been writing SMOS, which is a medium to large scale TUI itself, so I have a vague idea of what I'm talking about here. There's also my email address on the screen in case you have any questions after the webinar, but you can definitely ask questions during, and Michael will be taking care of that. Right, so why would you want to write a TUI in the first place? So a TUI is short for a terminal user interface. That means the entire user interface exists within a terminal. That's different from a command line interface, which happens by just entering a command, getting some output. A TUI is different because you don't enter a command and see some output. Instead, the entire user interface, just like within a GUI, now is in a terminal. So that means you have pixels the size, well, it's not true. You have these characters that are usually monospaced, and then that's the entirety of your user interface. It's usually not using a mouse that you interact with this interface, but it's more pressing buttons and less pointy clicky. It looks very old school if you like that. It's usually more snappy and more lightweight, and more importantly for this webinar, it's a lot easier to get started with. So that's what we're going to be doing today. There will be a lot of live coding in this webinar, and the idea is that you can code along. So I've prepared a GitHub repository that has the basic repository that we will be starting from, just to speed things up a bit. Before I go on with the explanation of what we'll be doing, I'm sending you this link already so you can download it beforehand and already run stack install, and maybe even get stack set up if you haven't done that, so that you can follow along once we get building. So if you just clone this repository and run stack install, then you'll be ready to follow along in a few moments. Okay, so the first thing I need to explain is the brick architecture. To write our first TUI, we will be using the brick library. Now, brick uses a very simple architecture, but it's important that you understand it before you get started. So the application starts with a starting state. The application maintains this state, and from the state and nothing else, you have to explain to brick how you want the state to be transformed into whatever appears on your screen. This is the drawing function. Then nothing happens until brick notices that some event has happened. This is either a keyboard event or a mouse event or some external event or a user-defined event. In this case, we'll only be dealing with keyboard events, only pressing buttons. Once bricks get such an event, you have to explain to brick what do you do with this event, and specifically, how do you transform the state when you get an event. Depending on the event, you do something different, but the only thing you can do is transform the state and some I/O. Then there's the new state. This gets then drawn with the drawing function again, and the cycle repeats until you somehow exit the application. Next up, this is the overview of a brick application. Now, there's a lot on the screen, so let me go through this one by one. A brick application has 3 type parameters. There is the state, so you can choose whatever state you want. There is a type parameter for custom events, which we won't be using, so we'll just leave it a type variable. And then there is a type parameter for the names of the resources that you'll be using. We also don't need this, so I'm just going to make a type synonym for called resource name, which is actually just a string. So you only need to pay attention to this S here. And then we need to implement 3 important functions. The other ones I've already done in the base repository that I sent over. There's a drawing function, which transforms the state into a number of widgets. Now, these widgets are in a list because they are layered on top of each other. In our application, we're only going to have 1 layer, so this will be a singleton list. You also have to define what happens when an event comes in. This is a function that takes the state, an event, which we'll get into in a moment, and it will do something, and you can imagine that event M here is just I/O because it's in fact a monad I/O. And then we will produce a next S. So that's either stopping, so halting the application, or continuing with a new state. And then there is a third function which turns your state into an attribute map. Now, this will become more important in a moment, but the basic idea is that widgets are a bit like HTML and attribute maps are a bit like CSS in that you can attach attributes to widgets, and then with the attribute map, you define what the attributes mean in terms of styling. So you could say a certain widget is selected, and anything that's selected must be red. And we'll get to that in a moment.
Sid, one question. Is widget an associated type or a dependent type?
No, it's just a regular type.
Okay.
Widgets is just the thing that knows how to draw itself on a screen, but it's not an associated type. I think there may have been some weirdness about this in previous versions of, well, actually the predecessor of Brick, but I'm not. I don't know enough about it to explain that well. Anyway, so at this point, I'm going to show you the base repository that I've prepared and that you should have along with you if you want to code along. So let's do that. I have it right here. I renamed it to Press because it's the presentation. And then on the right-hand side, I have another terminal that runs stack install file watch. This will continuously watch the source and then install the resulting executable whenever the build is successful. And then there will be a new executable on your command line called TUI, and it will error at the moment. This is intentional. Let's have a look at what's in here. Oh, first of all, in the executable is just the TUI function. There's nothing special here. In the library, there are a few things that I want to go through. The main function makes an initial state, gives the initial state to Brick using the Brick application that we're building, receives the end state at the end, and then we just print the end state. Nothing special there. We define our own TUI state to be a unit at the moment. We will change that later. We define the resource name to be a type synonym for string. Not very important. It just deals with a lot of ambiguities that you would get if you didn't do that. You could leave this just a type variable, but to make things simple in this webinar, I've made it a type synonym. This is where we define our Brick application. I've done the setting up there, so we only need to worry about the bottom three functions. The first one is build initial state, which will just build a state from I/O. The second one defines how to draw this TUI state into a list of widgets. So that's the layers. We will only put one thing in here, right there. And we'll get to that in a moment as well. And then there's a function that handles an event. This takes the TUI state, an event, and it will produce a next state. And what I've done here is I've said if the event is a VTY event, so that means it's not custom and it's not external, then if it's a keyboard input and the keyboard input is just the character Q, then stop. Otherwise, we continue with the application. Any questions there? I don't know how long to wait.
No, sorry, go ahead. No questions coming in.
All right. So the thing we're going to be building as a TUI today is just an example. And I figured it would be easy. It would be handy to learn by just following through an example and following along with what I'm building here. So the thing we'll be building is a directory explorer. We'll build it in stages, but the idea is that you can list the current directory and then hop through different directories within or upward and just look around. So in the first stage, we'll build a terminal user interface that accepts no input and just lists the current directory and nothing else. In the second stage, we also want to be able to have one of those entries selected and then scroll through them by pressing up and down. And in the third stage, we'll also be able to press enter and then go deeper into a directory by selecting one and then pressing enter. So the first thing we need to know before we can start building stage one is that you need to know how to draw the file paths, and you need to know how to get the file paths. So In Haskell, there is a function called getCurrentDirectory, which gets you the file path of the current directory. And there is a function called getDirectoryContents, which gets you the contents of a given directory. So we'll use those to get the contents of the current directory. And then once we've got those, there are two functions that we need to draw those on the screen. There is str, which turns a string into a widget that just displays the string. And there is vbox, which turns a list of widgets into a single widget such that all the widgets in the list are displayed vertically above each other. So let's go ahead and build this. There we go. So the first thing we need to do to change what is shown, is to change the TUI state itself. So we'll add to the TUI state the list of file paths that we're currently looking at. So that's just a list of file paths. And now the compiler complains, so we have to go and fix whatever it's complaining about. First thing to do is to change the build initial state function to actually populate this state. So we're going to get the current directory and then get the contents of that directory and put the result into the TUI state. There we go. Now the compilation succeeds, but if we run it, we still get an error because we have no way of showing what's in the state. So let's do that next. We have our TUI state here, and we want to produce a single widget. What we do is we draw a file path, and I'll define how to do that in a moment, over all the TUI state paths. And then we put those together in a vertical box. Now, draw a path creates a widget from a file path. And that's just the str function because file paths are just strings. Now I made a mistake. There needs to be ts at the end here. Okay, so if everything is gone right now, you should see the current directory contents by running the TUI. And you can press Q to exit. And there you see the resulting state, which is just the TUI state with the directory contents. There we go. That was stage one. Any questions before I go on?
I haven't seen any questions yet. Let's give it another 5 seconds.
Okay.
Can you please write the type of vbox and a comment in the source?
In the source, yes. There we go. And then there's true. Does that make sense?
And I've also provided a link in the chat to the function. Okay.
All right, let's go on then. What did I do? Oh, I did that in the wrong screen. Oh well. There we go. For stage 2. What we want now is to be able to have one of those selected, one of those contents, one of those pieces of content in the current directory. We want to have it selected and then be able to scroll through it. Now, to select one of them, we will need to be able to annotate the widget that is the currently selected piece of content by saying, now this is selected, and we want to show that somehow by saying, oh, anything that's selected, we want the foreground to be red. Now, foreground means the color of the letters, and background means whatever is behind the letters. So in this case, the foreground is white, and the background is bluish. And then, well, actually, let's do that first, and then I'll get to how you scroll through them. So the way we do that, no, actually, I have to explain the rest first. So the way we scroll through things, remember, you need to put everything in the state. So there is nothing that we can use while drawing other than the current state. So we need to both represent the entire list of contents and also which one is selected. And this concept is called a cursor. Now, in the case of our application here, what we want is to use a non-empty list cursor. So that means there is a non-empty list of contents and you're looking at a single piece of it. So if you would have a non-empty list, you can make a non-empty list cursor where the first one is selected and the rest aren't. Now this cursor represents both the entire list and also where you're looking within the list. And by modifying the non-empty cursor, you can change what piece you're looking at. Now, the implementation, you don't need to know about this, but just in case you're curious, the implementation of a cursor like this is actually two stacks and the current element in the middle. So there's a list of items that come before the current element, which they're in reverse order, so that the first element is the closest. There's the current element, and then there is a list of elements that come after the current element. And if you want to go to the next element, what you do is you pop you push the current element onto the previous stack, and you pop one item off the next stack and put it as the current element. Now, obviously, if you're already at the end of the list, then this won't work. So that's why this function that selects the next element returns a maybe non-empty cursor. Clear so far? Because we're going to use this now. Let's go to the demo.
Go for it.
All right. So we will need to import cursor.simple.list.nonempty. Does that work? Yep. And then we change the state. We need to change the state to contain a non-empty cursor of file paths instead of a list of file paths. Now, a few things will go wrong. First, we need to change how the building of the initial state goes. Namely, we need to make a non-empty list. And we do that by importing two more things. There's first import data.list.nonempty, and we import only the non-empty type and constructors. And then we also import that module qualified. There we go. And now we can say any.nonempty of the contents. This makes, I'm going to write that down. Makes a non-empty cursor, a non-empty list from a list, and it can fail, obviously. So if it fails, then we say, oh, well, just die. There are no contents. The reason I'm fine with dying here is that this never happens. There are always two entries in a directory. So then we have a non-empty list. And then we can say make non-empty cursor of the non-empty list. And there we go. Oh, I need to import system.exit to have the die function. Okay, so the state's been modified. The building of the initial state works now. And now we need to handle the concept of going up or down, let's say. So that's an event, which is a key. The key is keyed down. There are no modifiers. And what we want to do is change the state such that the contents of the state, so the non-empty cursor, has selected the next element. So let's get first the non-empty cursor out of it. So that's TUI state paths of the S. That's the non-empty cursor. Now we want to apply non-empty cursor next to this non-empty cursor, but this can fail. So if it fails, in that case, we want to still continue with the application, but now we want nothing to happen. So we just continue with the current state. If it succeeds, then we get a new non-empty cursor, in which case we want to put that back into the state and continue the application. What did I do wrong? I need to do it here. What else did I do wrong? It's not pure, but continue. What else did I do wrong? Oh, the drawing needs to be changed as well. Let's get to that in a moment. Non-empty cursor, select next, isn't it? There we go. Okay. So now let's actually do the same thing for up, but instead of next, we use previous. And there are nicer ways to do this, but I want you to get the idea. Okay, next thing, we need to change the way these things are drawn. So now we can't just put the paths in a list, draw all of them and put them below each other, because now we need to differentiate the ones that are selected and the ones that aren't selected. The way we do that is we look at the contents of a non-empty cursor. There are three parts. There is non-empty cursor previous. There is next, and there is current. We want to somehow draw all of them and put them in a VBox again. For the ones that come before it, we want to reverse those because they come in order that is closest to the current element first. Then draw all of those. The current one we just want to draw as is. And then we want to draw all of the ones after the current one as well, like so. This should work. No, what did I do wrong? It's not mconcat, it's concat. And there's one more problem. This all needs to go into a singleton list. There we go. So now we've drawn everything as we used to before, and we've handled the event, but we haven't made the change where the currently selected element is actually differently colored. If we just run it now, then you see no difference. And you can scroll up and down, but you don't see any difference, so you don't think it doesn't work. So we want to actually make a difference between a selected path and one that isn't selected. So I'm going to add a new argument to this drawPath function. And I want to pass in false for the ones that aren't selected. And I want to pass in true for the one that is selected. Now you can argue Boolean blindness, but I'm just going to give you an example right here. This still compiles. All right. So then if the selection is happening, then we want to say, give this thing an extra attribute, which is called selected. Otherwise, do nothing with it. There we go. And now we want to also add the idea that if something is selected, then the foreground of it should be red. And now I'm going to have an import error. That's right. And that's in graphics vty.attributes. And I need some more for FG. That's in brick.util. There we go. And now we have a little TUI that displays the current directory, and we can scroll through it and see the red selection move up and down. This is stage 2. Any questions up till here?
No questions coming in yet. Just give it another few minutes, a few seconds.
Yeah. I went through this a bit quickly, so if anyone's following along, the questions may take a few more seconds to arrive.
All right, I think we're good.
Okay. In that case, for step 3, we want to be able to go into the directory deeper. So the 3 functions we need to know about. We need to change the current directory of where we're looking to the directory that we selected. So that's with set current directory. Again, this is probably not the right way to do things, but for this example, it's fine. We also need to be able to check if the currently selected thing is in fact a directory. We can do that with does file exist or does directory exist, which checks both if the current thing, if the given file path exists as a file or as a directory, and that it is a file or a directory depending on which function you use. And then we also need lift IO to lift an IO action into this event monad. So let's do that. So which key do we want to go deeper? Let's say we want enter. Now, what do we do here? We want to set the current directory to the file path in the state that is currently directed, so currently selected. So that's non-empty cursor current of these paths. Then, so this will give me a compile error because I have to give it the next state. continue with the state. Actually, we don't want to continue with the current state because we want to continue with whatever state we get when we look into the new directory. So what we want to do is build initial state again from the new directory. And then I want to lift IO the setting of the current directory and the building of the initial state. And I need to import control monad IO pass. And current requires an T at the end. There we go, that should be it. And now we can scroll through. There we go, we can press enter to go into and out of directories. Out of is just by selecting the two dots to go up. And then we can go down again. All right, now the problem with this is if you select a file and then press enter, then you get an error and the application crashes and it says, this is not a directory, so you can't change into it. So let's change that as well. Let's say, does directory exist of this supposed directory? If this is a directory, then we can do the changing such as we just said. Otherwise, let's just do nothing. There we go. And now it shouldn't crash anymore when you select files. Excellent. That's exactly what I intended. Perfect. So that's stage 3 done. Now, if there are any questions up till now, feel free to ask them. Otherwise, I'm going to go into the bonus exercises. If you're following along, there are some more things you could do, but I'm not going to do those in the webinar, most likely.
Before we get to the bonuses, we had a question earlier on that I was saving. Now's a good time. Is this presentation itself, are the slides written in Brick?
No, or wait, I don't know actually. The slides are written in Markdown. So that's definitely not Haskell code. This is just Markdown. The application that I use is called Patat, which is short for presentations atop of the ANSI terminal, which uses Pandoc to convert the Markdown to something displayable, and then it might be using Brick. I'm not sure. I can't tell actually. Let me just check. Anyway, it's not written by me.
It doesn't look like it has a dependency on Brick.
No. So it looks like Patat just uses raw colored output. If that's true, then no. Okay, never mind. So no is the answer.
Okay, and I have not seen any other questions come in.
Okay, so then there are a few more bonus exercises in case you wanted to do some more at home. There is fixing the problem that the app crashes if you select a file. We've actually already done that. Then there is a bonus question to draw a border around the app. I can actually do that. That's not that hard. And then there is something that's a bit more difficult, which is to display the files and the directories in different colors depending on what type of content they are. That's about all the content I have, actually. So let me just quickly show you what it's like to add a border. The way you do that is you import brick.widgets.border. That works fine. And then when you're drawing the TUI, you want to add the border function around your widget. Et voila, now you have a border. There's actually a problem with this where the selection attribute goes into the border somehow, and it's not been fixed yet, but it's not, I mean, I didn't write Brick, so I can't fix it, but I've reported it is what I mean. There we go, that's about it. Can I check if there are any
There's
questions?
a question coming in. If you can give a small overview of Brick.
A small overview. Was that the question, a small overview?
Yeah, so I believe, yeah, I think that yes. I believe the question is an overview of what Brick is and how, yeah, what it's doing.
Oh, so I don't know too much about the details. I'm mostly familiar with using it. So from what I understand, Brick is built on something called VTY, which deals with the interface with ncurses. And there used to be a library called VTY UI, which was the predecessor of Brick, which was much less declarative than Brick is actually. And that was deprecated, and then Brick was written so that you now have a fully declarative Brick architecture style library for writing your TUIs. So there are some more things that you could be doing in Brick. So there is the borders, the styling. Then there are now also forms. So you can actually make forms in an applicative manner, like you could in YESL, for example. You can also there are certain widgets pre-made where the selection that I meant is actually implemented for you in a list widget. But it's hard to deal with if you want to change any of the specifics. That's why I wanted to go with a more fundamental approach of using a cursor. What else do I need to explain about Brick? No, that's about it. These are really the basic building blocks.
Another question that came in, how easy would it be to draw the directories and files differently?
Well, you need to somehow distinguish between what's a file and what's a directory. So instead of a file path, you would have to have something like piece of content, which is either a file or directory, and then store that instead. And then instead of drawing a file path here, we want to draw a piece of content. And if that's a file, then we want to say this is a file. If it's a directory, then we want to still draw it with string, but give it another attribute. There we go. Anything else I need to change? Oh, right. The entire building of the initial state needs to change now. So here you would have to differentiate in get directory contents. For each of these contents, you have to check whether they're either files or not. So you need to do does file exist on this thing. If it's a file, then we want to return that it's a file. Otherwise, we want to return that it's a directory, which is not exactly correct, but you get the idea. Anything else? 4M is not in scope. That's in control.monad. And now instead of is directory here, we can actually just case match on the currently selected thing. If it's a file, then we do nothing. If it's a directory, then we do the switching. What else? That should be it. And now we need to style these directories and these files differently. So we can, for example, say, if it's a file, then make it red. If it's a directory, then make it yellow. Does that work? Okay, so now the selection doesn't work anymore. I'm not sure why. I would have to look into it. It's got something to do with the order in which the attributes are applied. But I think what you can do to fix that is saying something selected and a file. I'm not sure if this is the right order, but we'll see. Nope. All right, I don't remember how to do that, but there is a way to get this working. I just don't.
It turned both the selection and the file are red. Is that the problem?
Oh yeah, maybe. Let's make this blue. Nope, that wasn't the problem. Let's see if this changes something. No, I forgot how to do it. Actually, if I, instead of with other, I say, whoops, other, then I think it's going to be replaced. Yep, there we go. Now that works. So now you can see you can select the blue ones and you can select the yellow ones. Make sense?
Yeah, people are saying yes. So a few other questions. Are there higher level UI elements available, like composing a form without having to construct everything manually?
Yes, about the forms, there is recently, not on Hackage yet, but in the, no, actually it's on Hackage yet. It's on Hackage already, I mean. Can I show that? There we go. So there's brick.forms. It says this is experimental and will probably change, so watch out with it. But yes, so you can make forms, and there are tutorials about this. There is actually the very nice module here. No, it's not a module. It's on here. There are these programs in the programs directory of the repository, which have just a whole bunch of examples for you. And there is also a form demo that shows you how to do this. I hope that answers the question.
We had two different questions about multi-threaded applications in Brick. So one is, can you send events to Brick app from another thread? For example, events about changes of directory contents. Another question, hi, could you share some thoughts about structuring Brick as an interface to something multi-threaded async? Like imagine you select a file in the program, it uploads it somewhere in the background, showing some progress bar for it.
Okay. So let me first answer the first question, whether you can send events to Brick. Yes, definitely. There is a separate main function. So we use default main, which just takes an application and the initial state. But there's also a custom main, which allows you to supply a B-chan, which is a Brick channel, which is just something like a channel. And you can use it to send events to the Brick application of this custom type that was a type parameter that we ignored. So if you use a separate thread to just feed things into this channel, then Brick will process them as channels and will ask you to update the state every time one of these events comes in. So you can here write bchan. So you just make one of these channels beforehand and then start sending things into it from another thread. About the second question, if you can send events out of Brick, yes, that's also possible. So if you want to upload a file in the background after having pressed enter, that's definitely possible. You do the same thing, but in the other direction. You make a channel beforehand, you have Brick send events into it, and in another thread, you do the actual uploading.
Okay. One last question. If anyone has more questions, please drop them in. Otherwise, I'm going to consider this the last one. The question is slightly off topic. What extensions are you using for Vim, or are you using NeoVim?
I'm not using NeoVim. What extensions am I using? I'm using Vim Indent, which does the indentation fixing. So if I have a wrong indentation, it will fix it. So this normalizes the entire Haskell code, so I don't have to think about formatting. I also use uCompleteMe, which just allows me to complete these things. I think that's about it.
Okay. One other question that came up. Can you have deadlocks with these channels?
Oh, yeah, absolutely. You have to watch out that you don't. I mean, if you have multiple channels, you will definitely have deadlocks at some point, but that's something for you to take care of. But if you only send things to Brick, then there won't be any deadlocks. And if you only send things away from Brick, then there won't be any deadlocks. You really have to have an actual deadlock happening. So two things that wait on each other and don't make progress.
Okay, and one question that you're really going to appreciate. I'm accustomed to using test-driven development. What Haskell tool or library would you suggest for doing that?
For test-driven development in general, or I guess for Brick applications. So I'm not sure how to test the display. So I don't know about whether you can test the display or whether you even would want to do that. About the state changing, I don't think I've ever used anything in the event monad that for changing the event. So you could actually redefine this function to use IO and then test that function separately. That's all the Brick parts that you would want to test, I think. Then for general test-driven development, I usually use HSpec, and I mostly use property tests.
Okay, there are a few more tooling questions, and I'm going to ask the Brick question first, and then we can tie off with tooling questions, and I think we're going to have to call it there for time. So do you ever embed a Brick app into a higher level of component in your application, or just use the app directly?
I've never embedded a Brick app. So I have never done it. I don't know if you can, but I haven't done it.
Okay, cool. So then the questions about your workspace. Is the shell ZSH with omyzsh installed?
Yes, that's right.
Is there any other funny stuff going on there?
Yes. So this funny stuff is going on here. So that's just the number of items in my getting things done in tray. I'm not going to show you what's in there.
Okay. How do you make stack build immediately on saving?
Oh, that's a great question. That's you do stack build or install or whatever you want to be doing, and then file watch. This is a lifesaver. So in this case, we were using in stack install file watch, and that will just rebuild whenever you save the file.
Cool. How did you make your make the fast reformatting of the code each time you saved or hit enter whenever it did it?
That's Vim indent.
Okay. And where are you getting the type hints coming from? I think it was the autocomplete stuff that we were seeing on the screen.
I don't think I got type hints. I get word hints. So this will say bool because I've typed bool somewhere else in this file, but for no other reason.
And what feature of Vim is doing that?
That's you complete me.
Okay. And is this all inside Xmonad?
Yes.
Okay.
Are people decomposing my desktop?
I think you're going to have to do a separate webinar at some point on how you set up your desktop.
I'd love to.
Have we ever tried Haskell IDE engine? That's the last question. Have you ever tried a Haskell IDE engine?
I haven't.
No. Okay. Cool. All right. Everyone, this has been a great set of questions. Sid, this was a great presentation. Thank you very much for giving it. For everyone who's listening, there's going to be an email sent out once the recording is available. It'll have links to the code. It'll have a link to the video. It'll have a link, I believe, to the slides as well. And we should be able to get that out in the next 48 hours. So again, thank you everyone for attending. Sid, thank you very much for presenting. Everyone have a good rest of the day.